Howdy, my name is Adrian Correa. I'm with Pulaski Technical College in North Little Rock, Arkansas, and today we're going to go over an introduction to weatherization for quality control inspectors. A little bit of explanation here. I know that some of you are going, why are we talking about the Weatherization Assistance Program? I don't work in that program. Well, we need to talk about doing the job of the quality control inspector in view of some kind of set of rules. The QCI certification is a portable credential, which means that you can go from one place to another with it and one program to another, or work in multiple programs at the same time. And there are some skills and some knowledge that you're going to have when it comes time for you to take that test for the certification. And you need to understand how working within a program affects your certification and vice versa, how your certification affects working within that program. And part of what we're going to help you do, or one of the ways that I'm going to try and help you to do that with, is by putting this in light of an established program with established rules that anybody can go and look at. It's a fairly transparent program, and that's the Weatherization Assistance Program. So in order to discuss that, you need to be a little bit familiar with it. So we're going to take a few minutes and go through this. So we're going to discuss, and I hope that by the time that you're done watching this and going through here, that you'll be able to discuss the historical perspective of the Weatherization Assistance Program. Where did it come from? What has it gone through in order to get to where it is today? And it serves a client base of low income, low to moderate income, but primarily low income households. And we're going to talk about some of the characteristics of this demographic that we serve, these folks that we serve. So you should be able to come back and again name some of the characteristics of that client base. And then also I'd like you to be able to recognize that we use building science to select the measures that we install. Just about every program does. The principles of building science are the agreed upon facts or criteria about how heat moves and the way things function within a building to determine what we should do to that building, in other words a home, to make it more energy efficient. And then I'd hope you'd be able to describe the principles of cost effectiveness and the savings to investment ratio. We'll talk more about what a savings to investment ratio is, but it's exactly what it sounds like, so there's no big mystery there. And then also be able to recognize some modern weatherization measures. What do we do today as opposed to what did we do in the past, and again, why? So the mission of the Weatherization Assistance Program is to reduce energy costs for low-income families, particularly the elderly, people with disabilities, and children, while ensuring their health and safety. That's very important. We don't want to go in and change somebody's home to and try and help them save money on their energy bill and wind up creating a situation that hurts people. So the way the money in the organization here is set up, everything starts at the top. Okay, it starts with the Department of Energy, and they have different project management centers across the country, primarily Golden, Colorado, and NETL, and the Department of Energy headquarters in Washington, D.C. They get money from Congress in order to support this program. That money is then granted to the 50 states, the District of Columbia, several Native American tribal organizations in 5 different territories. And then they turn around and grant that money to over 900 local agencies. The agencies were established under Lyndon Baines Johnson during his war on poverty. And the reason for that is when you give money from government entity to government entity, generally government entities and people that work for them are relatively immune or hard to get at as far as enforcing rules and get them to comply without a lot of politics becoming involved. However, a not-for-profit community action agency, it's pretty simple to take somebody to court and prove criminal intent or fiscal irresponsibility, and fiscal means money, that they did something they shouldn't. So that's one of the reasons that we use community action agencies instead of just the state doing this program on their own with state employees at the state level. And then we also, the last step of that money is the grant to the low-income household. The work is granted to them, and hopefully it's going to save them some money. Alrighty, so the process is basically, first of all, we have to find people that want this, who wants this. And then we have to determine whether they're eligible for it. And then we have to go through and decide when they should have this done based on their eligibility. So we have a point system in most states, and we give preference to households that have elderly, those with disabled residents, and those with children, because those are generally the hardest hit monetarily by their low income status and energy consumption, because they don't have the same earning power, or it's conceived that they don't have the same earning power as an able-bodied younger person or differently abled individual who does not have a disability challenge or have kids in the household. The auditor will then take a look before going out and familiarize themselves with the client file. Find out where they're going, what they're going to be looking at to a certain degree, and they will then go and visit the site. On this initial site visit, we do testing, we do interviews, we collect data, we look for health and safety issues, etc., to address. They then create the audit and develop a work scope. Okay, that work scope is then implemented by a crew or a contractor. All right. Once they're done, they do their own final inspection. The crew or the contractor should look and go, yep, we got it all, it's in good shape. Then the agency should go out, and this is where the QCI comes in. The agency should go out and do a final quality check on the home to be sure, and client interviews to be sure that what the program was supposed to deliver in the fashion it was supposed to deliver it, all of that has been done properly, and that the client is satisfied with it. And then generally there's some client follow-up that goes along after that. Okay, a little bit of history. I may have my slides out of order here. I do. Okay, hang on a second before we get there. Characteristics of low-income households. These are important to understand because these are the types of households we're going into to do work on. So what kind of people are we finding here as far as some very broad statements go? Well, one of the things that we can say is that they have the characteristic of being low income. That's one of the requirements for being in the program. And over 90% of these low-income households that we serve have an annual income that's less than $15,000. That's not very much at all, especially when you're talking about multiple people living in the family, more than one person. And then more than 13% of these low-income households have a household income of less than $2,000. Okay, that's really low. And then according to DOE's Energy Information Administration, low-income households spend about 14.5% of their annual income on energy, while other households only spend about 3.3%. So if you round that up, you see other households are spending about 14%. And actually, I think these numbers have gone up. I think the 14.4 is now at 17%, which is very high if you stop and think about it. That's almost 1/5 of the money that they bring in. Okay, and then the average energy expenditure, in other words, how much do they pay for their energy bills, is about $1,800 as of 2011. And the other interesting thing about these homes is that about 34% of these homes have elderly residents in them. So now we get to the history. From 1976 to the early 1980s, this is what we call first generation weatherization. This is when it started. And it started in Maine as a program called Weatherization. It was administered by the Community Services Administration and was later managed by the Federal Energy Administration. It relied primarily on volunteer labor, and they used very low-cost measures, and there was little or no accountability for money. There was really no in-depth oversight or accounting done, so it was kind of a wild west of a thing. They did what they could, and did what they thought was going to be right, but it wasn't driven with studies or reports or facts. It was pretty much touchy-feely kind of stuff. Okay. From about the early 80s to the late 80s is what we call the second generation of weatherization. And again, it used volunteer labor, but this time from the Comprehensive Employment and Training Act under the Department of Labor. Most of the measures that it installed were very temporary, a good bit of them. There was little or no diagnostic technology. They did not have manometers and blower doors and combustion analyzers that they used. And then along comes something called Project Retrotech. And this was a paper energy audit, and it allowed users in the areas that were using it to figure out the difference in R value in the home from one area to another area of the home, from one part to another. So it didn't assume that all of the building shell was the same, and then do some very basic heat transfer calculations. Okay, this is before we started relying on manual J calculations. We were using something called Project Retrotech to do some heat loss calculations to figure out just how big a heating system should be in there and might be in there when we get done if we hit our targets. And basically it just addressed the building envelope. There was nothing else that it was really looking at. And you had a blow and go type of attitude, which was a program for addicts that completed houses quickly. It got, the numbers counted very, got the count up, but it didn't do a lot for the energy efficiency of the home compared to what we're doing today. What we're doing today, has a lot more impact on the bottom line as far as energy bills goes. And then in the third generation, this is in the 1990s and primarily the beginning of the 90s, it used paid professional labor. It addressed both the building envelope and now the mechanical heating systems. It also included diagnostic tools. Now that wasn't nationally, it was just in some states, but some programs were using diagnostic tools, and many of the parts of the program were computerized. This was the beginning of computerization of the program, which made it a little bit easier to compile data and take a look at it and analyze it and figure out how well we're doing. And then state and national evaluations were also conducted in the 90s to determine how effective the individual grantee programs were, grantee first iteration, the state and tribal organizations and the territories, how well they were doing, and then also the national organization overall. And this is the first time that we've seen structured training and technical assistance made available and put in place. From about the late 90s and on, we're now in what we call the fourth generation. That's current. Okay, so we try and install measures that are permanent and cost effective. We don't want to put anything in that's temporary. Rental plans are in place, which means that now we don't work just for homeowners. We can also work for those qualified individuals that are renting property. Okay, this means that they can get weatherization benefits for the rental property that they're in. So, and that agreement means that the tenant gets the benefit, not the landlord. So if the landlord benefits from it somehow or another, they have to pass that on to the tenant. Okay. Health and safety plans. This is a biggie. We have health and safety plans that establish protocols for energy-related health and safety measures, such as chimney relining, faulty furnaces, CO detectors, smoke detectors, etc. And then also an increased use of advanced diagnostic tools in energy audits. This is probably the biggest change that we have made, because we are now going into an era in weatherization where we are testing to discover exactly how the building is performing under different conditions rather than guessing at what it is doing or approximating it. We have a much better approximation process based on testing. States can now leverage funds from other federal programs and often from utilities to expand the reach of their weatherization assistance program. That's something that's kind of new. and then the coordination with the U.S. DOE, I'm sorry, not DOE, but HUD, Department of Housing and Urban Development, allow us to do a very comprehensive, between these two organizations, we can do a comprehensive rehabilitation and weatherization project on certain types of residences. Okay, so that really has helped things out. Now, old school weatherization measures. What did we do in the past? A lot of programs, especially without strong management, turned into doors and windows programs. This was an easy way to make numbers. It made people happy, but doors and windows are really not something that save a lot of energy. So these doors and windows program or agencies, they were really into replacing windows, adding storm windows, replacing doors, weather stripping, doing a little bit of attic insulation, and caulking the heck out of everything. While doors and windows are really visible and they get a lot of people's attention, they're just not all that cost effective. The amount of energy that you lose through a window compared to or through an older window compared to what you lose through a newer window is not as dramatic as the energy that you lose through air escaping from the home or entering the home through air leaks or through the attic under certain conditions. So today we're doing the measures that save the most money and that are not as visible. We don't have a lot of people calling us and going, "Hey, I really like air sealing. Why don't you guys come and air seal?" Usually one of the dreaded questions for any auditor or QCI person is, "Where are my new windows?" Okay, so today what are we doing? What's different? Well, we're doing blower door directed or blower door guided air sealing. This allows us to locate leaks because we can see air moving through the movement of smoke or through the use of pressure differential manometers. We're installing attic insulation. We are dense packing sidewalls and attic floors. And overhangs such as cantilevers. We're now allowed to do heating and cooling equipment repair and replacement as needed. We're allowed to do duct sealing and duct modification for improvements there. We're allowed to now do electric baseload measures. This is something kind of new. We're looking at those things which are part of the energy bill, but are not the part of the energy bill that pays for heating or cooling. It's the other part that pays for entertainment and hot water and cold food, keeping our food from spoiling, this kind of thing, and lighting. So we're able to, right now we're changing out to compact fluorescence, I guess, as LEDs get less and less expensive and the technology becomes cheaper to produce. Then we're going to be moving towards LEDs. They seem to be able to produce more light with less energy, but compact fluorescence right now, I've got incandescence beaten hands down. Refrigerators, we discussed refrigerators. Refrigerators today perform much better than ones 10 or 15 years ago. But we don't want to make that assumption or that generalization and replace on that. We've got some criteria to replace refrigerators. And then the other thing is water heater modification and replacement. We can now modify water heaters by putting an insulation wrap around them, adjusting temperature on them. We can replace those that are defective or create a health and safety issue. So what do we get for all of this? Well, almost 7 million homes have been weatherized to date with federal and leveraged funds such as state and utility monies and fuel assistance program funds. Energy savings averages about 35% of consumption for a typical low-income home. That's more than 1/3 that we're saving them. And a favorable benefit to cost ratio of 1.8 exists. That means that we're getting $1.80 return for every dollar that we invest through this program. And the program supports lots and lots of jobs, both direct and indirect, and that's nationally. And those are jobs here in the United States. Okay, so cost effective. When we work on a low-income home and spend federal dollars on it through the WAP, we have some rules to follow. And this is what I was discussing, is that any program that you work with are going to have rules or is going to have rules for the way that you can spend their money or get a coupon or qualify for a rebate. So one of our things is cost effectiveness. We need a savings to investment ratio. And that's what we're looking at on the previous slide here when we say that a favorable benefit cost ratio. Now our SIR is not averaging 1.8. What that's saying is that we were gaining a benefit either community-wise or jobs-wise or otherwise of $1.80 per dollar invested in the program. And here on this next slide, we're talking about an SIR of 1 or higher. And that means a savings to investment ratio. So if I invest $1 in doing something, then over the life of that something, I need to get $1 back for it. And then it becomes cost effective, which means that I can avoid, by spending $1 now, I can help my client avoid spending $1 over the life of what I've just done. And then of course we've got energy related health and safety work that's not included in the SIR. We may have, we separate out those things that we do for either client or worker health and safety from the SIR. And we do this because we realize that some homes are dangerous, and some situations that we're going to change in the home may make it more dangerous. And we need a pool of money to correct those things and not try and justify doing that with an SIR. We do that out of a separate, well, it's not really a separate, we do separate it within the program, but it's still part of the overall program funding. We do that with a bit of money that we call health and safety, and different state programs, grantee programs, deal with health and safety a little bit differently. But let's just say that that's a pool of money that we don't have to cost justify. We don't have to go back and give a rationale for why it's being spent above and beyond. It's health and safety, and it's in our plan, and it's approved. We have really no federally mandated. At the DOE level, they don't say you can only spend this much on health and safety. Okay. However, really big requests for health and safety budgets can get the DOE interested in what you're doing, and they may want to know more about it. Basically, an SIR of greater than or equal to 1, of 1 or greater, then the measure is going to pay for itself over the lifetime, and that's really what we're looking for, is that measure pays off for the client. Okay, some states may include overhead costs in their cost-effective requirements, but this limits the weatherization measures that can be cost-effectively done to the house. I know that's a lot of cost-effectiveness thrown at you. Let me see if I can reword that. The money that it takes to run their office, drive their trucks, insure their people, pay their people, these are all called overhead costs. It's costs of doing business, and even a nonprofit has those costs. Okay, in some cases, states can include this in the money that they're spending on the home. However, this can limit what you can do to the house. Okay, because you may have a certain amount of overhead per home, and that's going to drive it back, as opposed to using an overall percentage of the budget. There are several different ways to do it. I'm just saying that, you know, some of them put them on there. Now, incidental repair costs may be included in the SIR, and in most cases, I'm sorry, let me rephrase that. Incidental repair costs must be included in the SIR. There is no may to it. It has to be. Incidental repairs are repairs that might be made in order to support putting in another energy efficiency measure. So let's say we're going to blow insulation into an attic, but we've got a small leak in the roof. Repairing the roof would be an incidental cost, and we're doing that to protect the insulation in the attic. Okay. Repairing a toilet drain, that might be something that comes under health and safety, because that's going to be an indoor air quality type of thing, as opposed to protecting an insulation measure. Okay. Alrighty. Typical savings payback. Let's take a look at a study that was done in Virginia. We're looking at 2 program years here, from July 1988 to June 1989, and then from July 1989 to June 1990. So you're looking at the change from old school to new school here. All right. So old school weatherization, doing caulking, weather stripping, replacement windows, storm windows, and attic insulation. Single families with gas heat saved about 10%, and it took about 30 years to pay that back. Single family homes with electric heat saved about 5%. It took about 21 years to pay that back. Mobile homes saved about 10%, and it took 53 years to pay that back. Okay, a lot of mobile homes that we go into are already old. They may not last another 53 years. Now, when Virginia swapped over to new school weatherization, they started using advanced air sealing, of course still attic insulation, but high density wall insulation, in other words dense packing, heating safety and efficiency improvements. And what happened was your single family site built, now what we're doing is just lumping gas heat and electric heat together. So on the high end we were saving 10% on gas heat. Now combined gas and electric, we're not making a difference between the two. We're not differentiating anymore. We're saving 24%. And it used to take 30 years to pay back that 10%. Now it's taking 10 years to pay back the investment to get a 24% savings. Mobile homes, we've dropped their payback from 53 years to 17 years, and we've added another 7% of energy savings to what we're doing. So to summarize this, the mission of the WAP is to reduce the energy bills for low to moderate income households. And typically the clients the people that qualify for this help have a very high energy burden. Modern weatherization, it's based on principles of building science and cost effectiveness. If we don't have a good reason for doing something based in science or health and safety, and it's not going to pay us back at least $1 returned in savings to $1 invested, then we don't do it. It's not cost effective and it doesn't make sense from a building science standpoint. The only other option that we have left is health and safety. So if it's not in the health and safety plan, it's not cost effective, it's not driven by the principles of building science, it doesn't get done. Okay. There are limits for spending on incidental repairs, but not for health and safety measures. Incidental repairs, you have a hard cap for each house that the state will generally define. However, health and safety, there's not a hard cap there. It's unlimited per household in theory, up to a percentage of the budget, whatever is in the state plan or the organizational plan, tribal or territory plan. The national evaluation of the program in the early 1990s determined that the program is effective at energy use reduction and jobs creation. So as a jobs program, this is a wonderful program. As an energy savings or an energy reduction program, avoiding new requirements for generating electricity and reducing the energy bills of older folks with disabilities, and households with children that are low income. It's another really good program. So I hope you enjoyed this little section and that you learned something, and that this puts into perspective the Weatherization Assistance Program, because this is the basis that we're going to use. The program that we're going to use is our model to go through and cover the rest of this quality control inspector class. So we'll see you in the next module.